So to find the work of this object, we need to use the work formula. And the work formula is that work equals the change in K. So work equals K final minus K initial. Work equals the kinetic energy final squared minus the kinetic energy of the initial. So we use this and plug in the values which we have from the problem, and W equals half. The mass is 1 times 100 squared, that's the final, minus half. The mass continues to be 1. The initial is 10 squared. So as we simplify that, the problem is half times, which equals roughly 5,000 joules, because it's newtons over meters. Now for answers, that's answer A. For B and C, we do not know what force did this, and it's oddly specific to being 5,000 newtons, so no, we cannot know it. And we cannot know the distance either, because it could either be 1,000 meters and 4 newtons, or it can vary a lot, so we can't really know for certain. And for part D, what does it mean that the object has kinetic energy? Basically, it just means that that energy can be used either way. It can move forward, it can move back, but this is positive kinetic energy. And basically that's it for this answer.